Good morning and welcome to this webinar, Paperless 101, Implementing a Digital Inspection System. This event, brought to you by Quality, is sponsored by ATS. I'm your moderator, Michelle Bangert, Managing Editor of Quality. Thanks for joining us. Our panelists include Nick Roncone. Trevor White is our first panelist. He's the Group Manager and Divisional Information Officer of Manufacturing and Engineering Systems at Toyota Motor America, North America. Trevor joined Toyota in 1999 and has worked in the information technology, or IT, field for 23 years. He also serves as Vice Chair on the Board of Directors for MESA International and has been recognized by CIO 100 and Smart Industry Top 50 Innovators. Next, we'll have Nick Roncone. He's the Business Development Manager, and John Colbert, Senior Application Engineer at ATS Applied Tech Systems. Nick has over 30 years of experience working with manufacturers of all types to define and implement projects related to improving the capture and use of quality data. John has consulted with hundreds of companies regarding their manufacturing processes to configure and launch electronic data collection systems that address their goals. You will see a couple of poll questions during the presentation. Please respond directly in the poll window, and the results will be discussed during the Q&A. Speaking of Q&A, don't forget to submit your questions, and later in the program, our presenters will address as many as possible. And now I'm excited to turn it over to today's first presenter, Nick Roncone.
Hey, thank you, Michelle. And as she mentioned, this is Nick Roncone, along with John Colbert from ATS. Thanks to everybody who's attending today's webinar, and I thank Quality Magazine, Michelle, for hosting us today. So we have a full slate here, a lot of information to share with you. Let's take a look at what we'll cover today. First, we'll review the shortcomings of a paper-based system, followed by a brief discussion with our Toyota panelist, Trevor White. We'll gain some insight there into Toyota's digital experience. Following that, we'll look at an implementation prep guide, and that'll help you gather the information together for your transition away from paper. After that, we'll actually work with a digital inspection system, both collecting some data and then showing analysis. We'll review a couple of case studies from companies who have actually gone digital. And then, as Michelle said, we'll finish up with the Q&A session, and we'll bring Trevor back for that. So let's get right to it. Framing the problem here that we're looking at today. Most companies have established quality gates throughout their manufacturing system. Maybe at incoming inspection, the fabrication area, there's typically a quality gate where those fabricated parts move into the assembly process. You may have final assembly inspections, as well as miscellaneous audits that occur during a manufacturing process, such as dock audits, maybe corporate audits, layered audits, and inspections of return material from your customers. So with a paper-based system, problems arise because it's not real time. People are writing down information on pieces of paper, similar to what you saw on the last slide. Those may be tick sheets. They may be graphics of your part where you're marking defects. You may have a checklist style interface. So those checklists not only have to be filled out, but then they have to be turned into somebody who typically keys that into a secondary package, such as Excel or sometimes your ERP or MES system. At that point, you'll get what is typically a general report, not something that's suitable or configured for a quality or process engineer in order for them to actually see what the root cause is and then improve your processes. So with a digital quality system, you're eliminating the lag time associated with filling out paper forms as well as the errors. And when you collect data, the data is automatically entered into a database, so that information is immediately available for real-time analysis. So in short, with paper, you can typically only get the low-hanging fruit. And with a digital system, you can react faster and better. Well, now we're going to talk with Trevor White from Toyota. Toyota is no stranger from trying to get all the fruit, not just the low-hanging fruit. And I'm sure we'll benefit from an overview of Toyota's experience. Trevor, thanks a lot for joining us today. I know you're busy.
You're welcome, Nick. Nice to talk to you.
All right. Our first question, which I think a lot of the attendees would like to know about, is, I guess, just in general, can you comment on some of the specific benefits that you feel our listeners would experience by going digital?
Sure, Nick. Yeah, just a little bit of background. behind our current situation at Toyota. We moved from a manual to electronic system approximately 15 years ago. We use an in-house custom client server based system with touchscreen to track any kind of issues from a quality perspective. We call them discrepancies, not necessarily defects. But it integrates with our global assembly line control production system. Most people call them their MES system. And also our element part quality installation instruction system, as well as our supplier quality information management system. So that kind of makes up what we call our QIMS, but quality information management system. Some broader capabilities that this provides to the business includes things like feed forward and feedback of defects, providing feedback to up or downstream processes. Nick was talking a little bit about the benefits of going digital from paper. Going digital allows you to in real time provide that feedback. So for us, if assembly is seeing issues with a specific spot or a specific part on a vehicle, you can have that feedback to the weld shop or the paint shop, or feed forward to our final inspection, for example, so that if we're starting to see trends of a specific issue, we can correct those before the vehicle leaves the plant, and that's the ultimate goal. Also integrates with our poke-yoke system, so things like torque guns to make sure that nuts are not under tightened, and we collect that information for long-term part inspection. Also, it integrates with our automated inspection. That's a big focus for us right now in terms of the broader capability. So we're moving to high-definition cameras with built-in machine learning to understand what issues that we're having from a quality perspective. So that digital experience is much better than trying to do it with paper. Also, from an audit perspective, making sure we're collecting measurements for long-term measurement quality from an audit perspective. And ultimately, what we want is a faster response to quality issues. We want to be able to contain defects, and we're able to do that with the system. Even provide part quality traceability all the way to for each VIN number, and reduce scrap. So that's a little bit of the broader activities that we have, Nick.
All right. You're assembling vehicles. My hat's off to you. You've been using a digital system for 15 years now, so you're definitely ahead of the game. I guess some of the folks online today will actually be implementing a digital system for the first time. Can you maybe, from a preparation side of things, can you share some important success factors with our audience regarding the planning and implementation of a digital quality system?
Sure, Nick. One of the big initiatives we have within Toyota is moving towards a truly data-driven decision-making process. So I would say that's first and foremost. So, data from the source will give you much better data to do problem solving. And we follow, very strict Toyota problem solving methodology. And having good quality data from the source is very important to support that. So the benefits that we see are being able to electronically record and visualize your inspection results. Like I said, we've got a touch screen. We have pictures so that you can drill into specific quadrants on the vehicle to understand where the defect or discrepancy is. It provides that real-time reporting and condition-based feedback so that you can prevent and fix discrepancies. And we don't want issues from flowing out of the plant. So we integrate with our assembly line control system. And if there is a open discrepancy on a vehicle, we don't allow it to be sold to our sales counterpart. We don't let it leave the plant, so to speak. We'll contain it in the yard if we have to. But so we ultimately want to prevent flowouts. We also are seeing a lot of benefits from a data analytics perspective. So that's, it's very important to companies right now to really look at those long-term trends and be able to drive problem solving and kaizens that we have internally to our product quality. So seeing that end-to-end from an analytics perspective is providing large benefits right now and really reducing problems that we see. even more so than we've been able to do in the past. Also providing the supplier quality feedback. We have a lot of supplied parts from tier 1, tier 2, tier 3 suppliers. So being able to provide real-time feedback on quality results to our suppliers is also a benefit that we see that's very, very important. Some of the news you've seen recently around supplied part issues, that's been able to be addressed through this activity. And then also within the plant floor, just reducing the walk time. Our system has a mobile inspection aspect that we call it AMA, abnormality management. But the group leaders and team leaders and plant floor workers have mobile devices, and they can pull that up and they can scan the VIN and correct the defect and close it out within the system without having to go back to a kiosk and a terminal. So there's a lot of benefit when you're in a high-speed manufacturing operations for that as well.
All right. Well, you certainly have a lot of areas where I think having a digital system is helping you. You mentioned those. Before you launched, or I guess for some of the folks that are about to launch here, can you mainly, share some important success factors with our audience regarding how they should plan for an implementation of an electronic system?
Yeah, it's a good question, and one that's recent. We just went through a major uplift of our quality, our manufacturing quality system, moving to a major uplift and spending quite a bit of investment on it. So I can definitely share some of the feedback based on reflection. So a couple of things. One is really, really strong business and IT collaboration. You got to have a common collaborative team working really, really closely together. You need to have top executive sponsorship that drives all the way down into your manufacturing operations from a plant perspective and have that consensus ownership. And then business needs to ultimately drive the implementation and execute, and IT supporting in more of a supporting role. For us, having a power user at each location to lead the training and implementation that really knows the business process and ensures that the system is supporting that, I think was a key success factor for us. The other thing is having a common platform. Although our system is distributed at each manufacturing location because of the criticality of it, having that common application platform and generating best practices. We actually have a best practices system that our functional and business leads can submit suggestions for best practice into. But having that group, that business group that collects those and promotes those best practices also made it successful. Probably one of the biggest things, though, Nick, is the gated project with formal checks that we did. So we had gated checks with the business all the way up to executive sponsorship through each phase of the project, and that ensured accountability with the business and making sure that we hit our targets. We also had on-site user acceptance testing alongside the business at each location, and we also had committed leads from each shop within the plant. So paint had a lead, stamping, plastics, weld, QC, and so on and so forth. Those committed leads would ensure that the processes are following the system as used as it's intended. So those are just a few of the success factors.
Well, it sounds like you got buy-in up and down the ladder. So I bet people are taking note of that to make sure that everyone's involved throughout their organization. I know you went through a lot of the benefits and you had some suggestions. Just taking a step back here, are there any other general lessons learned or reflection points that you'd like to pass along to our attendees today?
Yeah, it's a good question. And, one of the things we do, a Japanese-based company, is, bad news first. So some of the things that we focused on in the reflection that I would share with the audience is number one, and we avoided this. We had a few issues, but really we did avoid this because it's one of the lessons learned. We learned early and addressed it quickly. But make sure that you have a comprehensive infrastructure, wireless and security strategy, kind of that foundational infrastructure. For us, we have very, very large plants, and with the mobile devices that we have with the system, ensuring good wireless coverage and making sure that the system is connected and reliable and has a good foundational security structure is important. The other thing for us with our new system is that it moved quickly from a mission sensitive to a mission critical type of system, and making sure that the infrastructure is architected to support that mission criticality. making sure that you have hot swappable devices line side so that the members on the line can quickly swap those and keep the line running. Having a long-term sustainment team, I think, is one of the other things to make sure that you have and make sure you don't have an issue there. We recently implemented a new Scrum and Agile practice within IS in the last couple of years, and having a team that can manage the backlog and business priorities is some key lessons learned that we've applied some countermeasures to. Also documenting a comprehensive traceability and metric strategy, including reporting. You wouldn't believe how important reporting is to the business. And we had a lot of plants that had very, very unique reporting requirements that we had to, halfway through the project, we had to kind of get agreement on what those reporting core kind of gold standard reporting would be within the system. So I would say don't wait until you're already into the project to start that strategy. Those are some of the key things that I would say from a lessons learned, from a things to avoid perspective.
Well, those are some great points, especially making sure your infrastructure is in place, and then it's inevitable that you'll have to make individuals happy in terms of different reports, perhaps for different facilities, or in making sure everybody buys into a common set of reports. I'm going to move on now to the last question. This is kind of a fun one. You've been using a digital system for many years now. IoT is a hot topic. You've got the basics down in terms of a digital system. What are some technologies you're currently using or considering at Toyota? Maybe some of the new items that are available from a technology standpoint that you're implementing into your system.
Yeah, thanks for the question. This is a good one. It's a fun one. I agree. Really exciting activity that we're working on right now, and really what motivates our team on the plant floor that's supporting manufacturing. So, we're doing some cool, innovative things. I wouldn't say that it's not fully deployed across the board, but for example, wearables are all the rage right now. We do have a wearable program where we've got team members on the plant, on the line side plant floor that are using wearable watches that get and-on and line calls for alerts, including quality alerts. So, Toyota's known for our, traditional and-on system for real-time visibility, pulling the and-on cord. Well, now when somebody pulls the and-on cord, people see it as an alert that comes across their wearable watch, and that's been a big benefit so that they don't have to step outside of line or step to the side to try to figure out what's happening. Line leaders can see those very immediately and know exactly where to go and what to do. So that's been a big benefit that we're working on. Also, AR, VR, it provides some big benefits right now. We're seeing some benefits around element instruction and team member training, integrating that with our quality program. That's been a good, seen some good results from that. Also, this is probably the one that I think has the biggest potential benefit, and one we're really working on right now is getting all this quality data into our regional data lake. We call it Quality 360, but it really supports our early detection, early resolution initiatives, where we can take data coming from the customers, provide that very quick feedback to not only our manufacturing operations, but also our R&D operations from an engineering perspective, so that we can correct any issues that we're seeing or implement any kaizens we're seeing much faster than we ever have before through that data lake and analytics. And then ultimately, integration in the future to the vehicle DCM chip and allow us to do vehicle tracking and provide engineering feedback from the actual vehicles themselves through our Toyota Connected partnership, and has a lot of potential for the future in terms of IoT. A few things.
Well, you've come a long way from paper tick sheets. I'll give you that, Trevor. And I can't wait to visit one of your plants next time and see folks looking at their digital watches to get some feedback. So thank you very much. That was kind of fun for me. So we've learned a bit about Toyota's experience. We'll be asking Trevor to come back at the end of the webinar to answer some questions. But now let's move on to your implementation. I'm just looking at some of the poll results, and I can see that over half the folks online from an analysis standpoint are still using spreadsheets or paper forms. So Trevor's Trevor and Toyota are pretty far ahead in the game, but now let's see how you might be able to prepare better for your digital analysis and for your digital implementation. So I'm going to share my screen here, and I'm going to pull up what we call an implementation guide. Now, my company, ATS, is a global provider. We have about 30 years experience in lean manufacturing, Six Sigma consulting, implementation of MES systems, system integrations, PLC programming. I guess in a lot of areas that we would just refer to as industrial IT. So our experience has taught us, as Trevor's pointed out, that preparation up front is really a key to a successful project. So what you're seeing now is an implementation workbook that we use when launching a digital quality system. Now, you'll be able to download this and a few other items at the end of the webinar. But right now, let's just take a brief review here. Now, I'm not going to go through all these tabs, but the way the workbook is organized is that so you can put together all the information you'll need in advance of actually launching your system. So you'll see these tabs across the bottom. It starts with project personnel. Trevor mentioned how important it was. He mentioned how in each area, in each shop in his plant, they had a person who was in charge of implementation in that plant. They had management buy-in. The one comment I'd really like to make here is make sure on your team you have some current inspectors and operators involved. They're the folks that are collecting the data now, and they can really give you some insights into, hey, what information do we really need to capture here? What do we capture now? And they can help you produce an electronic interface for data entry that's going to both get you the information you're looking to capture and be able to do that within the tack time that you have to do the inspections and record the data. So after you've got your team together, I'm just going to highlight a couple of these other tabs. I usually tell people to start with the end. Trevor had mentioned that he worked with his plants to come up with a quote-unquote gold standard of reports that they can mostly agree with. There's always going to be exceptions, but it'll really drive the implementation and the development of your operator interface for data collection to know what you want to get out of the system from an analysis standpoint. So take a poll of your user community within your facility. There's basic things you're going to want for sure, like being able to access a Pareto chart of your top defects, perhaps be able to instantly see a listing of products that are producing the most defects. Trevor mentioned that they were doing graphics-based inspections. So if you have an image of a part and you're entering defects, perhaps it would be helpful in a paint or a welding area to get a concentration diagram, for example, showing you where your individual defects are occurring. Assuming you take your analysis and then implement changes in your process, you may want to get things like trend charts, see if you're getting better or getting worse. And then one of the things I want to scroll down and show you here is each process is different. So you might need some special analysis, like analysis by hour. If you have multiple machines doing the same process, you're going to want to capture the machine in your data collection interface. Maybe you want to, let's say, analyze by cavity or responsible cell, area, color. So think of the different ways that you're going to want to analyze the data in order to make an impact on your processes later, because that'll drive the configuration and what reports you use. Moving on here, there's some overall setup questions. Trevor mentioned that at Toyota, they use a lot of mobile people using tablets or mobile devices. So you'll have to think of that too. Who's collecting data? Are they operators at existing hardware stations I have in the plant, or will I need to implement tablets? Then you'll have some other considerations, such as are my parts serialized or not? Will entries be made on every unit inspected or sampling? So think of those types of issues, because that will definitely affect how your system is configured. So moving on a little bit, you'll be separating your plants into different areas and cells. In this worksheet, we give a few examples so you can kind of see what we're talking about, and that'll help you structure these sheets for your own facility. So you'll break down where you're going to have your stations and locations. One of the biggest efforts you'll have is deciding which products you want to start your implementation with. This is usually driven by things like customer requirements. You have certain reporting requirements that are driven by your customers. You'll have some products that are more high volume than others. That would be a low-hanging fruit target in my mind. And of course, if you have problematic products, those would also be places where you'd want to implement on those sooner rather than later. So if I have specific products, especially if they're assemblies, you're going to want to break those assemblies down and decide, well, what parts am I going to want to highlight and then report on later? So assuming here, for example, like I have a seat, well, there are various components in the seat, and during data collection, if I place a defect on a particular component, I can then Pareto-ize those defects by components later. So finally, what you're going to do is for each area, each process, each type of part, you'll be listing the various defects that you're inspecting for. You probably already have a list of these on your inspection sheets that you use at your quality gates. And then if you have a process that allows you to perform repairs, for each one of those types of defects, you'll put in, well, what are the possible repairs? And then during the repair process, your technician can note what they did to resolve the defect that they found on the part. Lastly, checklist questions are very possible. So if you have a certain listing of questions that you ask at different quality gates, you can simply attach your current paper forms and use that to configure your electronic system. So I just wanted to give a look there at this implementation guide. That'll help you start from scratch and organize your information. What I'm going to do now is go back to the presentation. And once you've actually prepared for your implementation, the next step is taking that information and turning it into a digital system. So today we're going to take a look at ATS Inspect software. It's of course offered by my company. It's pretty popular, but it'll just give you an idea of what's possible with a digital system. We're going to look first at collecting data, and then we'll take a look at what kind of analysis is possible. So let me share my screen again. And what you're going to see as I bring it up is the data collection module. So first I'm going to log in, or your inspector would log in. Now I'm typing in my login name, but one of the nice points of using a digital system is you can leverage technology. So instead of typing in information, whether it's an inspector name or you can see a box up here for serial number or other types of information, you can easily interface barcode scanners, badge ID readers, RFID tag readers, optical scanners. These are all pieces of equipment that you can use to get away from actually typing in information and the associated errors with that. The next item that is always a must is having some way to select the inspection product that I'm going to work with. Now in this demonstration here, I'm going to do two inspections, one of a component part, which will be a casting, and then we'll do an assembly. So here I'm going to pick from list. Now it could be a pick from list, but again, I could just scan a serial number with a part number or type in a part number. There's various ways to do that. So as I move down here, I have a group of products called castings. Below that, you see various part numbers and products that I have. So I would pick a knuckle as the part we're going to inspect. You may have other information. We talked about things like cavities, machines, etc. If there's information you're going to want to analyze later, in this case, operator, here I can make available a pick from list so your inspector can say who the operator was, and later on, as you'll see, we can analyze by operator. So once I select the part, there was a couple different types of inspections that take place. One of those was a graphic inspection. If you'll recall, I showed a paper sheet with a picture of a car. Well, if I'm doing a visual inspection, I need a graphic. And rather than putting X's on a piece of paper, I have the ability with a digital system these days to actually use things like a live CAD image of my product. You have these CAD images, you can import them into the system, and you can see here that as I look at the actual product and I want to place a defect on it, I can just rotate that image in free space to get the best orientation. Another mechanism you may want to employ to help get within your tack time are these thumbnails, these squares over on the right-hand side. As you see, as I press on those, they orient the part to a predetermined position that allows me to enter the defect at the right location. So let's take a look at entering a defect on a component like this. Now, by the way, I'm using a laptop with a mouse. If you have hardware that supports a touch screen, that is also supported by the software and makes it easy for your operators. Let's say I'm looking at this part and I see a crack at this location. So what I'll first do is just touch or click on that location, and the software is capturing the XY coordinates, and we'll work with that later. Secondly, I'm going to get a list of the defects. And this is if we go back to our implementation sheet, this list would typically come right off what you prepared ahead of time on your Excel spreadsheet. So first, I'm going to just enter the defect. And that could be as far as it goes. I may just want the location and the defect type. But often people would like to capture additional information associated with those defects. For example, you may rank your defects. Here I see major, minor, is it a scrappable defect or not? I'm just going to say this is a minor defect. Now, other information that may be helpful later, and again, think of in advance what you want your reporting to be. If you're going to want to analyze your defects by responsible cells and areas, you can have a list of areas and cells pop up for your inspector to say, this is the responsible area for that defect. We're looking at a casting, so a good real-world example is often those castings go next to a machining area. So if I uncover porosity during the machining process, I found the defect at machining, but the responsible area would be the foundry. So this would be a good example where I might have a responsible cell or area for the foundry that I can designate. Lastly, you should decide if you want to enter comments. A lot of customers need those for their documentation, so you can certainly add comments if you choose to. And if you're doing things like a customer return audit, warranty repairs, you're doing an 8D, here we have the ability to highlight this photo tab across the top, and I can take a digital photo and actually attach it to my inspection record. So when I'm done with that, I simply save that defect entry. I go back to the main screen, and now I have the ability to reorient the part and enter other defects. So again, it could be as fast as touching the location, picking the defect, and moving on, reorienting the part and doing so. So there's an example of what data collection looks like on a solid part or a component. Let me now go up to the selection screen, and now I'm going to pick an assembly. So I'll go here to a group of automotive products that I have, and we're going to pick a fire truck. I think this is a fire truck Toyota is going to be introducing. Sorry, Trevor, that's probably a spoiler for most of the people that are in the audience today. Now you can see one of the other things I wanted to show you is for this inspection, we're using just digital photos, like a JPEG or a bitmap image. So now I'm going to click on that image, and I'm going to get a larger image that I can use to collect data against. So here, for example, what's nice on an assembly is made up of various components. So here, if I see a defect on the bell, I select the bell and I see a list of defects that are specific to a metal bell, such as cracked. I enter the defect, I continue to look at the fire truck. Now let's say I see some splintering on the ladder. I select the ladder, I pick splintering. Again, I could put other details if I choose to. And then lastly, I'm going to put a defect on the logo. We're going to say it has an incorrect logo. So I've done my inspection from a graphic standpoint. I might also add that you can see this area down here in the left-hand corner. Usually to error-proof your data entry or to help new inspectors, you may want to make job aids, work instructions, things like that available so they can get a feel for what is a defect and rank them correctly. So here, for example, you could pull up images of what a defect like porosity looks like. I can move on to something more elaborate, such as a welding type of a tutorial. And these, by the way, would be linked directly to your existing job aids and work instructions. Lastly, this is very helpful. If your quality department wants to send quality alerts down to the floor, they can make those available to your inspectors too, to make sure they look for specific items. Now, we did a graphic interface. The other type of interface which is possible, you can see this tab across the top that says checklist. So a checklist is just like what it sounds like. So here I'm pulling up a list of certain items. These could come right off your paper checklist you're using currently. It's a series of questions. The first question I have is what type of metal is used for the bell. So it's kind of like an option content verification. I'm going to answer the question by clicking on one of the choices available. These checklist questions can be fill in the blank. They could be multiple choice. They can be measurements. So here I'm going to say it's chrome. Now, when I picked chrome, the software went on to my next question, and I can see that's because the software knows that the right answer per se was Chrome. So I get a green check mark, the software logs that as a correct answer, I move on to my next question. In this case, it is a measurement for trunk lid paint thickness. So over here, I can key in a value, but keep in mind, once you go to a digital system, you can really error-proof that system by hooking things like digital calipers or an alcometer or things like that directly into your software. So I enter the reading, and then I press this green button, which asks the software to compare that reading to the spec limits. Here I'm in spec, I get the green check, I go into my next measurement, which is a door to an A-pillar gap. Perhaps my inspector pulls out a caliper or an LMI gauge. I take that reading. Now here it compares it to the spec limits, and unfortunately it's out of spec. So I get a message telling me that, and then also what happens is the software shows, excuse me, the software shows a red X indicating that that was out of spec, and that has been entered as a defect against this unit. The last two questions I have are simply verifications, things like what kind of owner's manual am I using? Maybe some badge placement. Do I have the correct 4x4 badge placement? Things along those lines. So that combines both the checklist and the graphic interface. The last thing we're going to look at in data collection is usually in a plant like this, the fire truck, once it had defects on it, would move into a repair loop. So this software also supports the entry of repair information. You can see down here beneath the graphics panel, I'm going to click on this crossed hammer and wrench. That puts it into repair mode. So I can simply, as a repair person, look at what was entered previously by the inspector. I'm going to first repair this crack in the bell. So when I click on the defect and I say I want to repair it, instead of getting a list of defects like we saw earlier, I'm now displayed with a list of repair types that are specific to the bell. So I'm going to remove and install a new bell. I can add other details just like we could during inspection. And then I'm going to go back and repair the remaining defects. So you'll see here, if I go to splintering, I get a different list of repairs. I have a limited, I can just replace or scrap it. So I'm going to scrap the ladder. And then lastly, I'm going to go to the logo. And what I have available to do here is simply remove and install. And I could have had work instructions for the repair person showing them how to perform their repair as well. All right, so that is a look at data entry. There's a lot more to show, but that I think should give you an example of what it looks like. Now what we're going to do is move on to the analysis. So all of this data, by virtue of the fact that it's being entered into an electronic interface, means the data is immediately placed into a database. So now instead of waiting for the paper sheets to have their information key punched into Excel, now I can immediately go to this reporting module, which is web-based, and you can see on the left-hand side that there's about 80 different reports that I can choose from instantly to analyze that data. The way this interface is configured is I can select the different type of report I want on the left-hand side. On the right-hand side, you'll see a panel where I can pick filter criteria to select the data that is used to render the report. Okay? Now, the first thing that I'd like to talk about is a single unit history. Each individual unit has a single unit history. So all of the data that's been entered against that unit at any point in your manufacturing process is all stitched together in a single history for that unit. So here I'm going to select that report. I'm going to run it for a particular serial number. Over here you can see 50576. And I'm going to move these panels off to the side here so you can see what the report looks like. So what this is doing is taking all of the repair and inspection data that was entered throughout your process, and it's tying it all together under, in this case, a serial number 50576. So you can see that and other header information at the top. One of the things I want to draw your attention to is under the inspection section here, I can see the time and date stamp where each inspection or repair began, the elapsed time, what shift it was done on, what station it was recorded at, who the user was, and other information. Remember on the fire truck, we did a graphic inspection, so you can see a graphic of the part. Your defects are shown on that graphic, and then below here you can see the status, whether they were repaired or not. As I move to page 2 of the report, you'll then see the checklist questions and what was entered for those, and you'll see those green checks and red X's as to whether or not they were entered in correctly or incorrectly from a what is the right option or measurement standpoint. So all of these individual unit records can be pulled from the database, but also you can now do aggregate reports, which takes data from multiple unit records based on your filter criteria and gives you aggregate reports. A good place to start might be what we call a concern ranking. So here I'm picking a concern ranking on the left. That is basically a Pareto chart showing me my top defects. Over here on the right, you'll notice I could put in a specific time and date range. I can pick a specific product or a group of products. So as I hit the pull down, you can see that what I'm going to do is ask for defects across all of my castings, or I could have scrolled down here and picked an individual product such as that fire truck. But I'm going to select the castings. So what's rendering here is a Pareto chart for the time and date range I selected across all of my castings. So I look at this and I see that for the time and date range, which was basically a year, that cracks are my biggest problem. Well, really, this just causes me to ask another question, which is, do I have cracks across all my parts, or are the cracks associated with a handful of part numbers? So the beauty of a digital system versus paper sheets or Excel is that I can now click on this bar, the one that says crack, and now the software is going to immediately drill down and show me that of all my castings, it's the knuckle that's really giving me the most headaches from a crack standpoint. So now, instead of just wondering where my cracks are, I'm, as a quality engineer, I'm going to go to the process guy and say, hey, I got a lot of cracks on this knuckle. Can you help me out? Well, the first thing the process guy is going to say is, where are the cracks? Or where is the porosity? Or where is the short material? Because that will lead him to make certain changes in things like venting or gating or tooling changes. Now, we entered that data against a CAD image. So what I'm going to do now is go over to a Cad recording portal. We could have used just a JPEG, etc. But now you're going to see the power of having both the location and the type of defect. So for this knuckle where we entered data on a CAD image, I'm going to select my type of report, which is a concern spectrum. So just like we talked about previously, I'm going to pick a time and date range. I'm going to pick data from this month. We collected data on the knuckle, and that was the one that had the most cracks. So I'm going to move down here and I'll pick the knuckle off the list, and then I'm going to render the report. So this is just really a nice tool for your process engineer. You make 3D parts, now you have a 3D image. You can see I can rotate this part, and over on the right-hand side, you'll see an icon for each one of the types of defects I've been entering. So your process engineer can look at this scatter diagram and see things like, hey, where are my actual defects occurring? And that changes as I rotate the part. Another aspect to point out is this has a different icon and it's showing me all of my defects. Well, if I'm only interested in cracks, for example, as I click off on these icons on the right, you can see the various symbols disappear until all I'm left with are the cracks. So you can see multiple types of defects, single types of defects, but this really gives your process and your quality engineers actionable information to deal with. I'm going to go back to the main reporting screen here and just mention that you can also do that kind of analysis on a JPEG or a bitmap. This may look familiar to you if you're making them by hand. This is laying a 10 by 10 grid over a JPEG or a bitmap, and these color-coded ovals are showing me the prevalence of where my defects are occurring on the cell of that grid. So we've just looked at 3 different reports. There's 80. So the beauty of this is you can do things on a shoestring, like say, hey, do I have any kind of trend by hour? So on the left, I've picked a defects by hour. You can see here that I see the defects across the bottom. And just if I pick porosity, I can see for some reason I have a problem in hours 7 and 16 with my porosity. You may recall that during the data collection portion, I was entering in who the operator was. So now I can make a report that shows me defects by concern and operator. So this would highlight perhaps some training needs I need to address. John Colbert, who's sitting next to me, I have bad news for John. I can see that most of my defects are attributable to him. You can see that down on the table here. If I also look over, I can see that F. Rivera is probably due for a raise. And you can see if there's a particular issue that a particular operator has problems with. So again, you can maybe take some training issues up. You can do similar types of analyses by shift, by machine, by color. There are first-time yield reports, direct run reports, checklist reports. So again, we're eliminating the paper, but as you'll see shortly, the real payback here is going to come from the analysis and how that helps you reduce your defects and rework. So now I'm going to exit the reporting and stop sharing. Let me go back to the webinar here. So we've talked about the reporting and the data collection that's available, but now let's see where your savings might actually come from. I have another tool available to show you here. Let me share my screen again. And this is another tool that we've come up with at ATS. And the purpose of this tool is to help you calculate your current cost of quality and calculate the ROI in your investment in a digital system. Because let's face it, you're going to submit your project and the plant manager is going to look at these and she's going to say, well, I can only do so many projects. Which ones do I want to invest in? So you can prepare and use this sheet to help you show what is the current cost of quality and what would my payback be. There are certain areas from a digital system that you'll experience savings from. For example, you won't be using paper tick sheets anymore. So don't be concerned with the numbers I have in here. They're just ones I used as an example. But let's say you estimate that you spend 40 hours a week managing paper. So you can put in the number of hours, put in your labor rate. Here I'm going to put in $19. When I then move away from that cell, you can see here in the cost column, it shows you how much money you're spending in handling paper from a labor standpoint. There's a similar field down here. If I move down to how many hours you're taking each month for generating Excel spreadsheets. So there'll be a savings there, and I can enter that savings over here in column G. So I can estimate that, well, I don't have paper tick sheets anymore. It's probable I can achieve at least an 80% reduction in handling paper. And you can see when I put that percentage in, it shows me what the monthly savings is. The big hitters from a savings standpoint are going to be using the better information that you have to reduce your scrap and your rework. So here, for example, I have a monthly production of $3 million, and let's just say I'll put in a scrap rate of 4%. So again, that results in a monthly cost of scrap of $120,000. If I'm conservative and I just say I think I can get a 5% reduction in scrap by having better and more timely information to work with, you can see that from a scrap reduction standpoint, I'll save about $6,000 a month. So you can go through similar categories here, like eliminating sorting, eliminating trips to customers for spills you might have had by shipping non-conforming material, opportunity costs of lost production. So you can use whatever categories there are applicable to your process. This sheet will automatically calculate both a monthly and an annual savings. So let's say you're going to implement a digital system and your investment, as I've put here, is $100,000. Well, you'll also have ongoing costs. This particular sheet is set up for a 3-year analysis, but you can change that quite easily. Here, if I have a 2nd and 3rd year cost due to support maintenance agreements or things like additional training, I come up with a 3-year total investment of $152,000. Well, by moving down here to the last box, the sheet will take your monthly cost and savings, and then it will take your investment and tell you exactly what your 3-year savings would be and what your ROI is over 3 years, in this case, about a 10 times payback. So now, when your plant manager is saying, how am I going to get my bonus next year for my cost reductions, she'll pick your project over the robot that your fellow process engineer is suggesting. All right. I'm going to minimize these now and go back to the webinar. I'm going to stop sharing. And now we've talked about where some savings could come from. Now let's look at companies that actually implemented a digital system and what they found. So this first case study is from a major aerospace manufacturer. They manufacture and assemble jet engines. The place that they piloted a digital system was in an investment casting area, specifically the wax model area, if you're familiar with that. I'd like to draw your attention down to the benefits section, and you can see that by introducing a digital system and getting better data to work with, over this period, they were able to reduce their largest defect, which was wax bubbles or trapped air in the wax models, by 40%. So you can imagine what kind of savings you would have if you were able to take your largest defect and reduce it by 40%. If I move on, the next one is from a medical device manufacturer, TrueLife. TrueLife manufactures different types of implants and things along those lines. Their operators use the graphic interface to enter in visual defects directly into an image of the implant. And you can see both by having more real-time information and better analysis to work with that their product reject rate dropped significantly from 17 to 10%. They saved quite a number of units over using the system. And then a side benefit, which seems rather simple but is often overlooked, is they actually reduced their paper bill by 50% because the tick sheets have gone away. So I've told you a little bit about that installation, but we actually have a 1-minute video, and I'm going to advance here to show you the video. It takes a minute, and you could hear this directly from the customer's point of view.
Before introducing ATS Inspect, we carried out a paper-based system that was very time-consuming. As our product family increased, we found that this became more and more laborious, and as we were carrying out 100% inspection, this was in the arena of 1,600 to 1,700 products a day. ATS worked very closely with TrueLife, creating a bespoke software solution to our inspection process dilemma. ATS Inspect is a very intuitive product, and we found that it's perfectly suited for the input of data on the production floor. One of the unforeseen advantages was that our engineering team could spend more time fixing issues than collecting data. The increased response time has enabled us to identify the root cause of production issues quickly, which in turn has helped us to reduce our scrap levels. Our yield also increased, which gave us a return on investment for under 1 year. With ATS Inspect, we have real-time information available to us across our network anytime, anywhere.
All right. Well, I hope you enjoyed that video. I must say my favorite portion in that video is when the speaker says our engineers could spend more time fixing issues rather than collecting data, because I think that really sums it up. All right. Well, we've covered a lot of ground today. Now we're going to bring Trevor White from Toyota back on, and Michelle, the moderator, is going to serve up some of the questions that you've been entering during the seminar, and then we'll decide who's best to answer those, John Colbert, myself, or Trevor. So thank you again for joining. I appreciate it.
Thanks, gentlemen, for a great presentation. Before we have our presenters address some questions that have been submitted throughout the program, I wanted to remind you that we'd love your feedback in our webinar survey to help improve our program. So one of our first questions was, how long does a standard implementation take?
Well, I think, again, it depends. The scale of an implementation, such as what Toyota would do in an automotive plant versus what you might do in a foundry, is going to be different. I guess what I can speak for when we launch a system is we typically send out that implementation work guide, and we work with the customer ahead of time to gather all the information we'll need to put their system together. We typically come on site at the customer facility, and we use that information to train their folks and then implement the system with their parts and products. So we're making them self-sufficient to make changes and other types of adaptations while we're launching. So I guess the short answer is the initial implementation, and that typically is not an implementation across all your products, but an implementation of those products you want to highlight would be 5 days. Then normally the customer would then be adding products and expanding the use of the system across their various stations, and we might make a return visit after a month or so, help them tweak the system, do some consulting, and then it's just a matter of rolling it across your other assembly lines, your other areas for all your other products. So again, it might be a month or so in a small implementation as far as getting all your parts configured and in use. It might take several months in a place like a Toyota assembly plant.
Okay, great. And so then another question was, is it common to integrate with PLM and ERP?
All right. You know, Trevor, you've been using a Toyota and a digital system for quite some time. Would you mind commenting on that if you're still with us?
Yeah, sure. You know, we're a very, very large in enterprise environment. We do have some level of integration. It's not as much as we would like. So a lot of those systems, like our PLM system, we use Dassault CATIA, for example, on the vehicle side, and Creo for the unit. So that information does get pushed down to some degree and integrated with our quality management system, but not as much as you would get from an out-of-the-box small to medium-sized package. So some integration, not as much as we would like to see in the future as we start to modernize our application portfolio.
All right. Thank you, Trevor. I'd just like to add, too, that the question referred to, let's say, integration with a PLM system. But what I will say from implementing a lot of these systems is that almost always, and I'm sure this is the case at Toyota, a lot of the integration centers around getting information from your broadcast system or your ERP or MES system. In other words, when a car, in the case of a Toyota plant, moves into an inspection station, typically something will happen, such as reading an RFID tag or scanning a VIN number, and then the information in your digital system would be pre-populated by the option content for that particular unit. So there's integration that might take place with a PLM type system, but there's typically almost always integration with an ERP or an MES system to make the data collection task go faster and be more complete. Next question.
Absolutely right, Dave.
Oh, sorry.
Well, actually, I'm sorry, that's all the time we have today for questions. But please join me in thanking Trevor White, Nick Ronconi, and John Colbert for their presentation, as well as our sponsor, ATS. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. Please visit webinars.qualitymag.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience.